So the ratio for sine is the leg opposite the angle divided by the hypotenuse. So if we look at our picture, and I asked you, what is the sine of angle A? What's the length of the side that is opposite of angle A? A over C. So opposite side over the hypotenuse. Our second one is cosine, abbreviated COS. This ratio is the leg adjacent to the angle divided by the hypotenuse. So in our picture, what would cosine A be? B over C, the adjacent leg over the hypotenuse. Our third one is tangent, abbreviated tan, T-A-N. This ratio is your opposite side or opposite leg divided by your adjacent leg. So in our picture, what would tangent of A equal? A over B. Okay, these are our three trig functions. There's a total of 6. You'll learn the next 3 next year. Okay, these are the only 3 that we're going to learn here. Okay, as Shane had pointed out, what if we had chosen B? How would things have changed? So what now is opposite of B? B. And what's now adjacent to B? Does the hypotenuse change? No. So when you're doing these, if we were to change our angle, sine of B would become B over C. Cosine of B would become A over C. And tangent of B would become B over A. So it just, the numbers would go in different spots, but the ratio itself stays the same. Okay? So any questions so far on your basic trig functions? Just what the ratios are. Okay. So on this first example, we're just going to practice writing out the ratio. We're not solving anything yet. We're going to get to that after. We're going to start by finding sine of A and sine of C, cosine of A, cosine of C, and tangent of A, and tangent of C. I'm also going to show you guys an acronym that you can use to help you remember your sine, cosine, and tangent. Okay, so again, just like before, pick an angle to start with. Doesn't matter which one. Do we want to start with A or C? As long as it's not the 90-degree one. C, okay. So in relation to C, which side is opposite? C. What's your hypotenuse? B. And which side is your adjacent? A. So the acronym that you can use to help you remember your sine, cosine, and tangent. Sine is opposite over hypotenuse. So S for sine, O for opposite, H for hypotenuse. So for angle C, what is our ratio? So which side was opposite? C over B. Cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. A over B. Tangent is opposite over adjacent. So tangent opposite over adjacent. So C over A. So SOHCAHTOA is the acronym that we use to help us remember our sine, cosine, and tangent. You just have to remember how to spell it. Now, do you have to use this? No. It's just something that's commonly used. It's been around since I learned this in geometry. But it's just an acronym that can help you, thank you, remember your sine, cosine, and tangent. So there's our for angle C. Okay, what about angle A? So now how are we going to change things for angle A? Yeah. Can you wait till we're done? Yeah. Okay, what would be angle A? Or sorry, what would be our opposite to angle A? What would be our adjacent?
C.
And then how does that change? Or does hypotenuse change? No. So then what are the three ratios we have here? So what's sine? A over B. What's cosine? Cosine? C over B. And tangent? A over B. Or no. Opposite over adjacent. So A over C. So, before you go, what pattern do you notice here, if any?
They switched. It was AB for the cosine on the C, and then it was A over B for the sine.
And then same with cos
Same
A
the other
and
way.
sin C.
Okay, that's a test question.
And then they just switch over.
And then down here, they're reciprocals of each other. And that has to do with the switching of opposite and adjacent. But your test question around this is going to be something like, if sine of A is equal to A over B, what else equals A over B? You would have to know that it's going to be the cosine of the other angle that's the same value. Okay? Okay, any questions on just writing the ratio? Because this right here is half the battle of trig, is writing the ratio correctly. So are there any questions on just writing the ratio? Okay. So most of what you're going to be doing actually looks more like this one here, where we actually are solving for a side. So first thing you want to do, circle your angle so you know which one you're looking at, and label opposite, adjacent, and hypotenuse. So which side is opposite of 41? X. Which sides are hypotenuse?
32.
Not 32. What's across from the 90? The blank side. So our blank side's the hypotenuse, meaning adjacent would be the 32. So when you look at this, and we look and you try to use our SOHCAHTOA to help us, which trig function are we going to use? So when we look at 41 and what sides we know something about the opposite side, we know that it's x, and we know something about the adjacent side, that it's 32. So which trig function uses opposite and adjacent? So opposite and adjacent, OA goes with tangent. So that means we're going to set up our equation, tangent of our angle 41 is equal to the opposite side divided by the adjacent side. So any questions at this point? Because from here we're just solving. This setup is the key to all of our trig, is the setup. Okay, do you guys remember how to cross multiply? Yeah, so we're going to put the tangent over 1 so that I can just cross multiply. So 1 times x is x, 32 times tangent 41. And this is where our calculator comes in. So this right here is what we call calculator ready form, to where all I have to do is type it into a calculator. But you need to have a scientific calculator. Okay, how many of you guys have a scientific calculator? How many of you need to borrow one? Okay, to borrow a calculator, these are more expensive than the baby ones. I need something of value that I know I'm going to get mine back.
That's all.
Calculator and out, phone in. So come grab a calculator.
That's a dirty business you got going on.
Last year I lost 3. This is why I No, I didn't do it last year, but now I am. Hold up.
These are like what, 10 bucks?
These ones? No, these ones are like 25.
We give you our phone.
Yeah, just put it, wherever you take your calculator out of, just put your phone in that slot. Okay, I should have enough for everybody. So if I run out, I have another box. It's just not out yet.
I don't have a phone. You're using it right now. It's not copying the right
I think I broke my neck.
Okay, so you might be wondering why you can't just use the calculator on your phone. Your phone calculators are not programmed in a way that makes sense. Really, you have to type things in backwards. Whereas these calculators, even if you turn it sideways. Okay, does anybody have a Casio calculator?
What does that even mean?
It's a brand.
Man.
Like the yellow ones are all Texas Instrument. Anybody have something not Texas Instrument? Because again, Casio is sometimes you have to type it in backwards because of the way it's programmed. So when we're going through these, I'm going to do a lot of checks to see, are you getting the same answer? If you're ever not getting the same answer, tell me now, don't wait, because that means there's either something programmed on your calculator incorrectly, or you have to type it in differently. Okay, so again, no phone calculators, you need to borrow one. So how do you type this in? Once you get it here, we're just going to type it in exactly like you see it. So 32 times, hit the tan button, 41 equals. Tell me what you're getting as an answer.
32 times what?
27.8. So you're going to type in 32 times, hit the tangent button, and then type in 41. It should be above your parentheses.
27.81.
If you are not getting 27.8, we're going to round to the nearest tenth. So that's why we'll just stop at 8.
27.8.
Wait, so yeah, you got 27. No.
If you're not getting this, I need to know now so I can check your calculator.
I'm not sure.
Okay,
32 times, and then you
So no.
you're
So you do
gonna type the angle first.
times.
So 45.
And
And then it's 10. So yours is you just have to you're gonna have to utilize your parentheses, and whenever you do a trig function, you roll down
Okay. Anyone else not getting this answer?
Wait, it's
Yeah.
supposed to be in radians or degrees?
It's supposed to be in degrees. If yours is in radians, that's one of the things that could be getting you different or wrong answers.
What's a radian?
You won't learn that until next year. That's one of the problems that could arise with the scientific. That's why I wanted to make sure everyone's on the same page with this answer. Did you fix yours, Hasib?
Yeah.
Okay. All right. Next one. Again, we're going to be finding X. So once you have your picture drawn, label opposite, adjacent, and hypotenuse, and see if you can tell which trig function we're going to use here. Is it going to be sine, cosine, or tangent?
Oh, it's gonna be tangent.
You think it's going to be tangent?
No, I don't.
Okay, let's start off. Which side's opposite of our angle? So here's our angle. Which side's opposite? The blank one. Okay, but we're going to still label it just to make sure. Which one's the hypotenuse? 26, because it's across from the 90. And that leaves adjacent to be X. So we know something on the adjacent side and something on the hypotenuse. So which one uses adjacent and hypotenuse? Cosine. A and H, that's adjacent hypotenuse. It goes with cosine. So cosine 21 equals adjacent over hypotenuse. Put a 1 under and cross multiply.
What's the O stand for? Like, T O?
Opposite. Cross multiply. And we get X is equal to 26 cosine 21. Type it in and let's see if we all get the same answer. Let's make sure we know how to use our calculators.
19.60598.
I got one person said 19.6.
6. Oh no, never mind.
I heard 24.3. Huh?
24.27.
But we're rounding to the nearest tenth.
24.3.
Okay, it should be 24.3. Again, is anybody not getting 24.3?
I got 18 something.
It should be 26 times cosine 21. That's what the numbers. Anybody else not getting this as an answer? Did you get it?
Yeah.
Not yet? Did you get it, Nikki? Okay, on the next one, which trig function do you think it is?
Sin.
Sin?
No, it's tang.
Tang?
No, it's sin.
No, it's sin?
No, it's sin.
I
Is
like
it-
cosine. That one just sounds cool. We'll go with cosine. No, that I can't sine. Cosine sounds cool.
Okay, it is sine. So here we have our angle, opposite, and then across from 90 is the hypotenuse. So opposite and hypotenuse is sine. So we'll have sine of 33 is equal to opposite over hypotenuse. Put the sine over 1 so that we can cross multiply. 1 times 15 is 15. And then over here we'll have x times sine 33. Is x by itself on this one?
No.
No. What do we have to do to solve for x? Divide by what?
By sin 33.
Divide both sides by sine of 33.
By sin.
Okay, so that it cancels the sign out on that side. So what does x equal? 15 divided by sine 33, which will equal
24. No, 27.5.
you should end up with 27.5. So try punching it into your calculator to make sure you're getting that answer. 27.5.
He's not even close. You get 15.
Did you do 15 divided by sine 33?
You got 8 something. Yeah, I know what I did.
Okay. Okay, Nikki, did you get this one? Yeah. Okay. Okay, any questions on that one? How are we doing so far with trig ratios?
Pretty.
Usually the hardest part is figuring out which one you have.
Yeah.
The solving is going to be the same every single time. Okay, second to last one actually. Try to set up and solve this one on your own.
No, every time I just call it. Get your ass to this week.
Okay, anybody get an answer yet?
No. Still trying to figure out what I have.
Still trying to figure out what you have?
No. Yes. No.
How many think it's sine? How many think it's a cosine?
No, Nixon.
How many think it's a tangent?
It's tangent.
It's tangent?
I don't know. How do you tell?
Well, there's my opposite. So if there's my opposite and I don't know anything about it, what does that eliminate?
Cosine. Wait. I thought you just said what's the answer.
Sin. Sin.
It eliminates sine, because sine we need to know the opposite. What else needs to know the opposite? Tangent. So if it can't be sine and it can't be tangent, what's left?
Cosine.
It's cosine. So our hypotenuse is x and our adjacent side is 48. So cosine of 37 equals adjacent side divided by the hypotenuse. We put the cosine over 1, cross multiply and solve. So 48 equals x times cosine 37. We need to again solve for x on this one. So divide both sides by cosine 37. And what are you getting for your answer so we can make sure we're all plugging it in correctly?
60.1.
60.1. Okay, majority of your homework tonight is doing just this, what we did on these 4 problems. That's probably 95% of your homework. So are there any questions on those type? Okay, the last type are word problems. So we're going to do a word
I
problem.
think word problems in math is just not fair.
But this one actually could happen in real life. It's not like the
Oh.
train one. This is like a legit real life one.
Yeah, what? I don't see where sine, cosine, and tangent are going to come out of anybody's mouth in real life. It just did. I'm talking about not in math and
All right, so this one we're going to be talking about a ramp and how to build a ramp.
kind of like slant it. Like you make stairs, but you just fill in with like.
To make stairs involves trigonometry.
Okay. You can do it without that.
Can you?
I mean, it may not be legal.
There you
can
go.
still do it without it.
All right, so here we're talking about a ramp, and we're talking about one that is used to load suitcases on an airplane. Do I need to be worried about you?
I don't see it. How much out of it?
Okay, so why is it necessary to worry about a ramp that's being used to load suitcases on an airplane? If it's too steep, what happens? It falls backwards, or you have to get a really strong motor to get your conveyor belt to work. Okay, if it's too shallow, it might take forever. Okay, because it has to be a longer ramp if you're going for a shallower angle. So this one is trying to figure out what's best for both the motor on the conveyor belt and the plane size and all that. So a ramp is used on to load suitcases on an airplane. If the cargo door is 7 feet from the ground, and the angle formed between the ramp and ground is 25 degrees. How long is the ramp? Okay, if anyone has any desire to go into engineering or architecture, this is again something you're going to need to know, especially when it comes to the ADA rules. That's students with disabilities or people with disabilities. All those ramps, you need to make sure how long do they have to be to reach their end goal and not be at too steep so that they speed too fast down. Okay, we want to keep everything safe. Okay. So first thing you want to do is draw this out. Okay, so what does a ramp look like? There you go, there's your ramp. Okay, the ramp starts on the ground, so here's our ground, and it goes up to the plane. So this is our plane door right here. So we don't know the length of the ramp, that's our X. Do we know how high the ramp has to go? 7 feet, because the cargo door is 7 feet off the ground. Where does the 25 go? Where? Does it go up here or down here? Okay, so it says between the ramp and the ground. So ramp and the ground is going to be down here at 25 degrees. So how long is the ramp? So is this a sine, a cosine, or a tangent? Okay, so we have opposite, and we have the hypotenuse giving us a sine. So sine of 25 is equal to opposite over hypotenuse. Put the sine over 1 so that we can cross multiply. 7 is equal to x sine 25. Divide both sides by 25. And I already hear some people saying the answer. What is it? 16.6, because this is a word problem, we have to put the units. The ramp has to be 16.6 feet long.